Hello and good morning, everyone. This is Shakil, and today we are going to discuss some important topics from Unit 1 of AS Physics, that is Physical Quantities and Units. And the topics that we are going to discuss today, the topic is 1.2, and which is units, SI units. And we're going to learn something about the units, and then we are going to learn derived units and how to express derived units in terms of SI base units. And then number 3, we are going to discuss about homogeneity of physical equations. And then in number 4, we will discuss some of the prefixes that we use in AS physics. So let's begin the proceedings. So first of all, we know that all the quantities are divided among two groups. The first group is base quantities and the other group is derived quantities. The base quantities are considered as the fundamental quantities and they are independent. It means that they are actually not made up of combination of any other quantities. So they are independent actually. Okay, and there are 7 SI base units. First of them is length, time, mass, temperature, electric current, amount of substance, and then finally light intensity. About derived quantities, these are not fundamental and these are made by a combination of 2 or more base quantities. And the example is, let's say, speed, which is combination of distance divided by time, area, which is combination of length and width, volume, which is a 3D quantity, which is combination of length, width, and height, for of course a cuboid. For density, it is mass over volume. Mass is independent, but volume is like length into width into height. So it means you at least have to measure 4 quantities in order to measure density. That's why density, volume, area, speed, all of these are derived quantities. The next thing, is about how we express physical quantity. So we express a physical quantity with a value and a unit, right? The value is, of course, a numeric value, a numbered value, and unit is like which will be accompanying this value. So if we talk about system of units, the first is SI units, that is System International Unit developed in 1971. And then there are like 2 types of units, base units and derived units. So base units, all the base quantities have base units, like for length, it is meter, for time, it is second, for mass, it is kilogram, for temperature, it is Kelvin, for current, it is ampere, for amount of substance, it is mole, and for intensity of wave, it is candela. If we talk about the derived SI units, these are actually the combination of SI base units. So for example, speed is distance over time and distance is having a unit of meter and time is having a unit of second. So it means that the unit of speed is meter per second. So this is the derived unit. Similarly for work, its unit is joule, which is named after the scientist. But if we express that in SI base unit, so we know that for mass, it is kilogram, for acceleration, it is meter per second square, for distance, it is meter. So when you combine that up, it is kilogram, meter square per second square. So it means joule is a derived unit of work, which is equivalent to kilogram, meter square per second square. So this we'll be doing in every question, that every quantity will have 2 units. One is the derived and one is the SI base unit. Remember, in SI base unit, we will be only using 7 units. Okay, so moving forward. We have to look for quantity chart. We have to, like in this, we'll make a list of all the quantities along with their symbols, equations, and units. And then we'll be making a list of the new quantities that we will be studying in AS level. Then we'll be list a quantity with no unit. And then we will be making list of some challenging and fractional quantities. Okay, so the next thing is we have to look for some quantities that you have studied previously, like area. Its symbol is A, and its equation is like length into width or pi r square. Its SI base unit is meter square, and derived unit is the same. Then for volume, it is V, and the formula is given along with units. So for density, for speed, for acceleration, for force, and for momentum. So what you can do is you can just pause the video over here, and you can carefully look for these 7 quantities with their name, what is their symbol, what is their equation, and what is their SI base unit, and what is their SI derived unit. For momentum, it is Newton second. For force, it is Newton, right? And for rest of all, their SI base unit and derived units are actually the same. Okay, moving forward to next quantities, which you have studied in your O levels. It is impulse of force, which is I, and it is equal to change in momentum, or F into T. Then moment of force, which is force into distance. Then elastic constant K in Hooke's law, which is F over E. Then work and energy, both are same things actually. Work is force into distance, and energy can be half mv square or mgh. And power, which is rate of work done or rate of energy conversion. And then pressure, which is force over area. So what I have done is I have just written the names of the quantities, then their symbol, then their equation, their SI base unit, and their SI derived unit. And as this is from O level, so I hope that you are getting the concept. Okay, then moving on to next quantities, which is from thermal physics, heat capacity. It is C, which is Q by delta T, where Q is the heat energy. Number 16 is specific heat capacity, which is small c is Q over m delta T. Then latent heat, it is Q equals Q, or L is the symbol, and Q equals ml. And then specific latent heat, which is capital L or small l, so it is Q by m. And then we go to wave speed, like waves, it is V equal F lambda. Then wavelength is V over F, and frequency is 1 over T. So all these quantities, what you have to do is you just have to recall, because you're already done with O levels, with these quantities in O levels. Okay, then amplitude, it is A or X naught, and it has got no equation. Its SI base unit is meter. Okay, then charge, let's go to electricity. Charge is Q, which is IT. Electric current is I, which is Q by T. EMF is work done per unit charge. Potential difference is again work done per unit charge. Resistance is V over I. Resistivity is rho equal RA by L, and electric power is P equals IV. So these are the quantities with equation, and then their SI base unit and derived units are there. Like if SI base units are with question mark, it means we have to find that, and that's the thing. And if there is a cross in SI derived unit, it means there is no derived unit for it, or the derived unit and base unit are same. So just pause the video over here and then carefully recall all of these quantities with their symbol, equation, and units. Okay, moving forward, now let me introduce you with new quantities that you'll be studying in AS level. The first one is motive power. It is P, which is P equal FV. F is force and V is velocity. So its unit is watt, derived unit. We don't know about SI base unit. We will work out for that. Time period of pendulum, it is T, which is 2 pi L over G, where L is the length of pendulum and G is the gravity. And of course, time period have got unit SI base unit second, and there is a cross at derived unit. It means its derived unit is same as base unit, that is second. Then gravitational field strength is G, which is force acting per unit mass. Force unit is Newton, mass unit is kilogram, so it is Newton per kilogram. Then electric field strength, E, which is F over Q. Force is Newton and charge is Coulomb. So its derived unit is Newton per Coulomb. Then stress is like pressure. This is the symbol sigma. Sigma is force over area, so it is similar to pressure. That's why it is Pascal. Then strain is epsilon E. It is a Greek letter, which is change in length per unit length. It has got no unit, because change in length is meter and length is also in meter. So both units canceled away. Young modulus, it's actually for the checking the strength of the material. Young modulus is stress over strain, and its unit is similar to the stress or pressure. Then wave intensity, it is energy transferred by a wave per unit area per unit time. We don't know about SI units, we'll work out for that. but the derived unit is energy is joule divided by area is meter square and time is second. So it is joule per meter square per second. Energy of subatomic particles, it is E like electron, proton, neutron, alpha particle. So that energy is actually QV, and it has got a unit of um, derived unit of electron volt. So EV is electron volt, electron volt. And actually it is equivalent to joule, but the thing is there is some other value for this as well. Okay, let's leave this phase difference. Let's move on to the next, the fractional quantities in AS level. Fractional, like the quantities coming in the fraction. So the first one is mass per unit length, M by L, that is kilogram per meter. Then rate of volume flow, which is volume divided by time. So volume is meter cube and time is second. Number of charges per unit area. So number is N and area is A. Number has got no unit, so it is 1, and area has got unit of meter square. So the unit is per meter square. Then fractional change in length, delta L over L, it has got no unit. Then quantities with no units, strain has got no unit. You have already done that. Efficiency has got no unit. And ratio of similar quantities like delta M over M, delta L over L, delta T over T. So of course it would have no unit. Moving forward to most important part, which is the type of the question. So let's study type 1 now. Type 1. So type 1 is expressing a given derived quantity in terms of SI base units. That is kilogram, meter, second, Kelvin, and ampere. So these kilogram, meter, second, Kelvin, and ampere, these are actually SI base units. So you have to convert any given derived unit in terms of these units. So what will be the method? The method will be, first you will see that if they give you Newton, if they ask you to convert Newton in an SI base unit. So your first step would be identifying the quantity, that Newton is unit of which quantity, right? So you'll figure out, okay, Newton is the unit of actually force. Okay, then you have to write the equation. What is the equation of a force? That is F equals ma. Then you have to look for SI base units. So what is the SI base unit of mass? It is kilogram. What is the SI base unit of acceleration? It is meter per second square. And then you need to simplify. If simplification is required, then you will simplify it. If not required, that is your answer. So it means that Newton is the derived unit of force, and that is actually equivalent to kilogram meter per second square. So that is your answer. So first you need to thought about quantity, then you have to write its formula, and then you have to put SI base units in the formula, and make sure that your final answer would be only in the form of these units, which is like kilogram, meter, second, Kelvin, and ampere. So you have to try now for this joule, watt, Pascal, coulomb, ohm, volt, ohm meter, joule per kilogram per Kelvin, and watt per meter square. So you have to use the same method that I have described in this slide. Moving forward is, let's say, example for volt. Like the question is, this is the most common question in the exam. Express volt in terms of SI base unit. Like in your answer for volt, kilogram, meter, second, ampere, or Kelvin, or a combination of any of these should be coming. Nothing else than this. So as I told you, first you have to look for the quantity. So what is the quantity that is having a unit of volt? It is EMF. Okay, second one is write its equation. So EMF is work done per unit charge. Okay, fine. Then, if you know the unit of work, you can simply put that. But if you don't know unit of work, you have to further simplify work. So work is force into distance and charge is current into time. Then you can further simplify force into mass into acceleration. D is itself written, and I and T. Now you know units of all these quantities. Like for mass, it is kilogram. For acceleration, it is meter per second square. For distance, it is meter. For current, it is ampere. And for time, it is second. So the last step is simplification. So you'll be adding or subtracting the repeated units. So kilogram is coming one time. Meter is coming two times. So you see that both the meters are like this meter and this meter. They are having power of 1 and 1. So over here, it will be M2. And then again, second is repeating. On numerator, it is S minus 2 and denominator S1. So when you take denominator S1 on the top, it would be -2 -1. So that will be as -3. So that's how you get this answer. So volt equal kilogram meter square per ampere per second cube. Okay, moving forward to type 2 now. Type 2 is finding SI base unit of a quantity in the given equation. Let's say the equation is given, which is F equal KRV, and they have told you that F is force, R is radius of the object, and V is speed. And now they are asking you to find SI base unit for K. So find SI base unit for K. So now what is the method to solve such questions? First of all, you will make the equation as subject, the quantity as the subject for which you have to find the unit. So as you have to find unit for K, so from the equation, make K as the subject. So K equals F over RV. Then you have to then you have to do the simplification. Simplification means that like F is MA, so you just replace F with MA over RV. Then you have to put SI base units. So for mass, it is kilogram. For acceleration, it is meter per second square. For radius, it is meter. And for velocity, it is meter per second. Then you need to simplify it. So like meter is coming 2 times, so meter will be cancelled, 2 meters will be cancelled and 1 meter is left, and then 2 seconds are there, so you'll add their powers. So it means that your answer is kilogram per meter per second. So the unit of K is kilogram per meter per second. That's how you solve such type of questions. Okay, let me tell you some further example in this regard. Suppose this is the equation F equals capital M small m over R square, where F is the force, capital and small m are the masses, and R is the radius or distance between center of 2 masses. And what you have to do is you have to find the unit of G. So you have to find SI base units of G. So the first step is making the subject. So make G as the subject. So look, you have made G as the subject, which is FR square over capital M into small m. The second step is simplification. Like if you know the units of all the quantities, then you can simply write that capital M, small m, R, you know all of them, so you can simply write them. But if you don't know the direct unit of any quantity, you have to write its equation like F equal MA. Now, as you know, in all the units, so put the units of all these quantities and simplify it until you get G. Okay, this is the second example, and what you can do is, where F is the force, Q, capital Q, small q are the charge, and R is the radius. And what you have to do is you have to find the SI base unit of K. So what you can do is you can just pause the screen, write this expression yourself, and try to work out for it. And then you can look for the answer. On the second slide, the answer, this is the answer. So just do it yourself, right? The question is on the previous slide. So do it yourself and then check the answer. Okay, again, there is a challenging example. What you have to do is the expression is written over here, which is like T equal 2 pi L over X. So what you have to do is you have to find SI base unit for the X. So you know that 2 pi is not having any unit, it is a number, so you can ignore that. And you can make X as the subject, and then you have to substitute the units, and then you have to simplify for that, right? So do it yourself, although it is done over there, and its answer is coming out to be meter per second square. Okay, another question, R equal rho L by A. So you have to find the unit of rho, which is resistivity. So making rho as the subject, and then you don't know the unit of R and A. So you have to work for R separately. It is done over here. R is V over I. And then V is work done per unit charge. And I is like, I is like current. So this is work over current into charge, and work is force into distance, and charge is IT. So you keep on simplifying. For force, it is MA, and rest is simplified. So then put the unit. So you got a unit of R over here. So when you gain the unit of R, you'll be putting it over there in R. And for area, you know it is meter square. And for length, it is meter. So you simplify it to get this answer. Okay, the next one is P equal V square over X. You have to work out for the unit of X, where P is the power, P is the power, and V is the potential difference. So P is the power, V is the potential difference. So you can see it's working. And finally, for the X, this is the unit. You have to use the same method. First, make X as the subject, then work out for the units of power and voltage, which I have done. For voltage, it is done over here, and for power, it is done over here. And then you put both the values in the formula to simplify it. So pause the video and solve it yourself, and then look for the solution, which is shown in this slide. Moving forward to type 3 now. Type 3 is to show that a particular quantity in a given equation has got no SI base unit. Like you have to prove that an equation is given. So in that equation, one particular quantity would not be having any unit. So like energy is E is X mv square. So you have to show that X is having no SI base unit. So for that, what is the method? You have to make X as the subject. You have to insert the SI base units after simplification if required. Then you have to simplify the whole expression. And if your answer is 1, like no unit is left, then you will say that that quantity has got no SI base unit. So look below. I've done this. It's working like X is energy over mv square, making X as the subject. Energy is work. So work is F into D. F is MA into D. So MA into D, you have simplified it, and mg square is already simplified because you know the units. So just put the unit for mass. Okay, for mass, it is like this. M and M are already cancelled away. For acceleration, it is meter per second square. For distance, it is meter. And for velocity, as velocity square is there, so that's why it is m2s minus 2. And when you simplify it, the answer is 1. So when answer is 1, so you have proved that X has got no SI base unit. So this is another thing, T equal X square root L by G. So T is the time period, L is the length, and G is gravitational acceleration. You have to show that X has got no unit. So you have to do the same thing, make X as the subject, put SI base unit, solve that until you got answer of 1. So pause this video and solve it yourself and then compare your answer. Moving on to some challenging question in type 3. And let's say it is like X equals C epsilon square into E, where C is the constant having no unit, and E epsilon is the strain, and E is the Young modulus, which is actually equivalent to pressure. So what you, and this X is elastic energy per unit volume. This X is elastic energy per unit volume. So you can also write it as elastic energy per unit volume. So it is energy over volume. So you have to show that C has got no SI base unit. C has got no SI base unit. Why it is challenging? Because it is having too many different quantities like X and E. So what you have to do is you have to make E, you have to make C as the subject, right? But before that, the strain, let's talk about strain. It is delta L over L. It has got no unit, right? And then we talk about Young modulus. Young modulus is stress over strain, sigma over epsilon. And as epsilon, strain has got no unit, so it is only F over A. And then F is MA and area is A. So just put the units. We have already done this before. So the unit of Young modulus is kilogram per meter per second square. Okay, now we have to work out for X. Like we are working for the separate units. Like first we worked on strain. Second, we worked on Young modulus, and thirdly, we are working on X, and then we'll put all of them in the equation to prove that C has got no unit. So X is energy per unit volume as stated over here. So energy is actually work and volume is volume. Work is F into D, and you know, like the unit of force is kilogram meter per second square, which is MA. D is meter and volume is meter cube. Just simplify it, you'll get the unit of X. Now what you have to do is you have to put all the three units of like x, epsilon, and e in the expression 1. So c equals x over epsilon square into e. So for x, its unit is there, epsilon has got no unit, and e has got this unit. So when you simplify it, 1 is left. It means c has got no SI base unit. Okay, moving on to type 4 now. And type 4 is finding the value of indices in an equation. What is indices? Indices is actually the power of any quantity. Like E is half mvx. So you're asked to find value of x. This is not about finding the unit. This is about finding the numbered value. So you're not finding the SI unit, but you're finding a number value. So what is the method? You have to simplify the quantities. Simplification means if you don't know the unit of energy, you have to put its formula until you know the unit of that quantity in the formula. Then you have to insert the SI base unit, then you need to simplify. And then you need to compare indices of similar units on both sides of the equation. So let's do it. Energy is half mvx squared. So energy is actually work, which is F into D, which is MA into D, and this is the unit of energy or work, which is kilogram meter square per second square. So just put it over there at place of energy. Half has got 1 over 2 has got no unit, so you can ignore the number. Mass has got a unit of kilogram, and velocity has got a unit of meter per second square per second, and X is its indices. So you have to compare indices of similar units on both sides. So let's compare indices of meter on both sides. So on right hand side, on left hand side, the meter has got a value of 2, and on right hand side, the meter has got a power of x. So it means x equal 2, right? So you got the value of x. Similarly, you can compare the indices of s on both sides. On left side, it is -2 for s, and on right side, it is minus x. So minus cancel away, so you got 2 as the answer. So that's how we can pick the answer. Okay, similarly, this is the practice question. You have to do it yourself. T is 2 pi L over G power n, and T is time period, L is length, G is gravitational acceleration. You have to find value of n. So I've done this. You can pause this to solve it, and then you can compare your answer. Similarly, another example is there, P equal I n into R. So P is electrical power, I is current, and R is resistance. You have to find value of n. So do it in the same way as I have described in the previous slide. If you are unable to do, you just have to go back in the video, and then you have to look for the type 4 description again. Okay, so over here, it is the solution of the previous question, P equal I n R, I power n into R. You can look for it. The solution, finally, n is equal to 2. So just look for the solution. Pause the video and look for the solution. Okay. Okay, let's move on to type 5, which is homogeneity concept. Homogeneity concept. In physics, we learned many, we are already done with many quantities. F equal ma, K is half mv square, pressure is force over area, pressure is rho gh, total pressure is liquid pressure plus air pressure. So all the correct equation in physics that we are done, they are always homogeneous. So all correct equation in physics are homogeneous. Now let's see what is meant by homogeneous equations. So the equations, these are the equations in which every term is having same SI base unit, every term. Now we have to see what is meant by term. So term means like F equals MA. F is one term and MA is second term. So two terms are there in this formula. Rho equals M by V. So rho is one term and M by V is the second term. So it has got two terms. So what is term separator? How do we know that how many terms are there? We have to look for the equal sign, negative and positive sign. If these signs are coming in the equation between the quantities, then the terms will be separated. But if multiply and divide are there, so that are not term separator. So like kinetic energy is half mv square, it has got two terms. Then total pressure is rho gh plus P naught. So this is actually, how many terms it have? It has like two terms only, right? Sorry, three terms. it has got three terms because total pressure is one, then equal is there, rho GH is second, and then plus sign is there. So rho naught. So it has got three terms. So whenever positive, negative, or equal sign are coming, they are actually the term separator. But if the quantities are written with multiply and divide sign between them, then they would be considered as a single term. Okay, moving forward to an example, like V equal U plus AT. This is first equation of motion. So this is final velocity, this is initial velocity, and this is acceleration, and D is time. So you know how many terms are there as the equal and positive sign are there. So 1, 2, and 3. So three terms are there, right? Okay, now we have to check the homogeneity, that whether this equation is homogeneous or not. So for that, what is the method? What is the method to check for homogeneity of the equation? So the method is you have to insert the SI base unit in all the terms. And then you have to simplify if required. And then you have to compare SI base unit of all the terms. If all the terms are having same unit, then equation will be homogeneous. Let's say in this, final velocity is having unit of meter per second, initial velocity is having unit of meter per second. And like if you work out for the unit of acceleration and time, for acceleration, it is meter per second square, for time, it is second. So when you solve them, it is meter per second. So it means all the three terms like V, U, and AT have same unit. So we say that this equation is homogeneous. This equation is homogeneous. Okay, moving forward to another example, S equal UT plus half AT square. First, S is distance, U is initial velocity, T is time, A is acceleration. You have to check the homogeneity. So how many terms are there? Three terms are there. S is first term, UT is second term, and half AT square is third term. So just put their unit. S is meter, U is meter per second, T is second, so its unit is meter. And AT square, A is meter per second square, and T square is second square. Both second square cancelled away, so it is meter. So as all the three terms have same unit, so we say that this is a homogeneous equation. In the similar way, you can work out for the homogeneity of this third equation of motion. Okay, now we have to look for subtype 2 of the homogeneity, finding SI base units of a term or quantity in a given expression which is homogeneous. They will give you an expression and they will ask you that this is a homogeneous equation and you have to find unit of a particular quantity in that. Let's say the total pressure equals to X plus rho GH, and they said that this equation is homogeneous, where everything is described like PT is total pressure, X is the unknown quantity, and rho is the density, G is gravitational acceleration, and H is the depth. So you have to find SI base unit of X. So what is the method over here? Method is, as the equation is homogeneous, so every term out of these three would be having same SI base unit. So you have to select a single term, put the SI base unit, simplify if required to get the answer, and that answer will be the SI unit of the unknown quantity. Because in homogeneous quantities, in homogeneous equation, every quantity will be having same SI base unit. So now we have selected total pressure from this. Total pressure is force over area, and force is MA. Area is area, you know. M is kilogram, area is meter, acceleration is meter per second square, and area is meter square. So just simplify it, you will get this answer, kilogram per meter per second square. So as the total pressure is having the unit of kilogram per meter per second square, so all the other terms like X and rho GH would be having the same unit. So that will be your answer. Okay, moving forward to subtype 3, complicated equations. SI base units of a quantity, you have to find SI base unit of a quantity. Let's say C equal alpha T square plus beta T cube, where C is the heat capacity. And you know heat capacity is the amount of heat required to change unit temperature. And T is the thermodynamic temperature in Kelvin. And you have to find the SI base unit of alpha and beta. So that is the question. You have to find SI base unit of alpha and beta in this equation, while C is heat capacity and T is thermodynamic temperature. So now how you will do it, as the equation is homogeneous, so you have to select a term with all known SI units, and then you have to compare and simplify. So let's see, we know the unit of C, that is heat capacity. So C is selected, which is Q over delta T. You can look in the quantity chart for its formula, which was on slide 4 or 5. So Q is energy, which is actually work, and it is F into D, and temperature is T. So just fill in the units of force, distance, and time, and you will get answer of C as this, right? So this is your answer of C. This is not the final answer because you have to find SI base units of alpha and beta. Now what you will be doing is, you'll be saying as C is equal to this, so as equation is homogeneous, so alpha T square would have the same unit as that of C. And then T square is Kelvin square, so just take Kelvin on the other side. So finally, your alpha answer would be equal to kilogram meter square per second square by Kelvin cube. Similarly, beta T cube was the second term, where and its unit is equal to C, which you have worked out. And then T cube is Kelvin cube, shift Kelvin cube on the other side. So that's how you can find the SI base unit of beta. Okay, now we have to move to type 6, which is finding a quantity from combination of given quantities and vice versa. So let's say you'll be given with combination of quantities, right? Let's say K into E square, and you have to find that this K into E square is equal to which quantity? So where K is elastic constant, it is like in the Hooke's law, you know that F equals KE, and from here, K equal F over E. We know this thing. So K is elastic, that elastic constant. E is the extension, right? So K is F over E and E is L minus L naught, right? Okay. So similarly, like many other, okay, the options are like momentum, force, energy, and weight. So these are the given option. You have to see that product of K and E square is equal to which of these quantities, whether it is equal to momentum, force, energy, or weight. So what is the method to solve such type of questions? You have to put the SI base units in the given quantities like K, E square. Just put the SI base units, simplify the units, and think about the quantity that is having that unit, right? To like you have to, or you have to visualize the formula, that if you know the formula in which K E square is coming, so you can straight away give your answer as that. So K E square, let's work out for that. K is F over E. So one E is cancelled away, so it is F over E. You know F is MA and E is E. So MA is kilogram per meter per second square, E is meter. So this is like kilogram meter square per second square. So now you have to think about the quantity having this unit. So it is actually energy. You know, energy is work, which is F into D, and that energy is having the same unit. It means that your answer would be this energy. Okay, moving forward to another example, you'll do it yourself. P square over m is equal to which quantity? Where P is momentum, m is mass. So this is the fractional quantity is equal to which of the given quantities, whether it is equal to energy, force, pressure, or volume. It is solved over there. You just put value units of P and M, solve them. And when it is mv square, so mv square, you will definitely find that mv square is actually half mv square. So this is actually kinetic energy, which is energy, right? So that's how you can get that. P square over m is equal to energy. Example 2, product of EMF and charge. So just solve it yourself, pause the video, solve it to yourself, and then you can work out for the answer. Okay, now a small topic, which is prefixes. You know, prefixes consist of two words, prefix. So let's say if energy is 5,000 joule, 5,000 is a value and joule is the unit. So it has got no prefix over there, but you can write it as 5 kilojoules. So kilo is actually a prefix, and kilo is written between the number and the unit. You can't write like 5 joule kilo. Kilo is always, prefix is always between the number and the unit. Let's say energy is 0.005 joule. It has got no prefix, but when you write it as 5 millijoule, then milli is the prefix. So why we use prefixes? These are used to express very large or very small amounts conveniently. So there are two types of prefixes. One is large value prefix, which is like kilo, it is K 10 power 3, mega, capital M 10 power 6, giga, capital G 10 power 9, tera is capital T, which is 10 power 12. And the small value prefixes are also there, which is like centi, C 10 power negative 2, milli, small m 10 power negative 3, micro is mu 10 power negative 6, nano is n 10 power negative 9, pico is small p, which is 10 power negative 12. So this is the basic knowledge. Pause the video and try to memorize the names, symbols, and along with their values. Now, finally, we have to look for the question types related to prefixes. So type 1 is the basic knowledge of prefixes. You should be knowing the symbols and values of the prefixes. Let's say 500 kilojoule, so you know that kilo is 10 power 3. 500 megaseconds, so you know mega is 10 power 6. Type 2, solving products of fraction having prefixes. So let's say 50 terahertz over 1000 megahertz. So you have to solve that. So tera is 10 power 12 and mega is 10 power 6. So just insert the value, simplify it until you get the answer. So that is equivalent to 50,000. So it's just putting the value of prefixes and simplifying them. The next one is type 3 in the prefixes, expressing one prefix value into other. This is the most important type. Like express 500 millijoule into microjoule. So they'll give you one prefix and they'll ask you to express it in any other prefix. So what is the method? First one, you have to remove the prefix from the given value. Like if you know the value of prefix, you have to remove that. For example, 500 millijoule. Milli is having 10 power negative 3. So you just wrote its value. So you have removed it. Number 2, make a pair value for new prefix. So you have to convert in micro. So make a pair value of micro. Micro is -6 and it's in its pair, same numbered value with opposite sign will be there. So this is the pair value of micro, having the original value and the value with opposite sign. Then you have to multiply the pair value with the given value. So this was your given value and this was your pair value. So just multiply both of them. And then you need to simplify. In the pair, we will come across one thing that as we have to give answer in micro and this is micro. So at its place, you will be writing micro and then you will be solving the other two, like the other, this one. So you have to solve these to get your answer. So just solve these to get your answer, right? 10 to the power -3 and 10 to the power +6. So it will be +3. So your answer is 500 into 10 to the power 3 microjoule, or you can write it as 500,000 microjoules. So that's how you can express one type of prefix into other. Okay, there is another example which you'll do yourself. Can express 5 nanosecond into milliseconds. So do it in the same way as I told you, and you can compare your answer with this. Pause the video, solve it yourself. Okay, the next is again the same example, express 2000 millijoule into megajoule into terajoule. So pause the video and work out for yourself. Like first, remove the given prefix, like mega is 10 to the power 6, then make the pair value for tera for the new prefix, which is -12 and +12, and then just multiply both of them together, and at place of 10 to the power +12, you can use tera. And then the next question is express 20 kilojoule into millijoule. So do it the same way as I told you. Okay, so now this is the end of the topic. You have to make notes, you have to revise them, and then you have to start solving the worksheet. Thank you very much, students. I hope that everything will be clear to you. If not, if anything is doubtful, you can always contact me on my WhatsApp number. And every one of you knows my WhatsApp number, 0334 870 9632. So you can contact me on this number in case you find anything difficult to understand. See you, inshallah, in the next video. And the next video is about vectors.